Hi. My name is Matteo. I will first set the context for this small use case. It's not really a project, it was more a use case in the context of the DARIAH project. So the DARIAH project is a project to build a digital infrastructure for research in the Arts and Humanities. Started as a project and is trying to become an ERIC organization. So an organization as a European Research Infrastructure Consortium. It's a European project but made of national branches with very different kind of funds that are available. And I'm working on the German branch. So the first phase started in 2011 and is finishing in 2014. And the first phase was about starting to build the technical infrastructure made of virtual machines, for instance, and the authentication layer, then some basic services like the persistent identifier service, and also some recommendations. One recommendation was about discipline-specific metadata, so which metadata should be used in a specific discipline. And another set of recommendations was more about interoperability, interdisciplinary interoperability, which is the recommendations I worked on, and in the framework of these recommendations I developed this small use case which I'm presenting as SkOSifying Thesaurus. So this is to give the broader picture. So interoperability can mean many things. It can be very general or very specific. The problem of implementing this in DARIAH was that there are many disciplines, going from history to musicology and to archaeology, like in our case. And if one wants to do semantic interoperability, which basically means data have the same meaning, they are referring to the same concept with the same meaning, and you want to do it across disciplines, then it gets difficult. So it's quite accepted that the more limited is the disciplinary scope in which you want to achieve interoperability, the more chances you have to actually have some success on it. So we look more at interoperability as interchange. So having two systems could be data repositories or collections or software trying to talk to each other without trying to avoid as much as possible the human interaction, although it's not possible to remove it completely, but at least to reduce it. And we looked at some key aspects. The first one is APIs and protocols. So as a minimum standard as an API, we recommended OAI-PMH, for instance, as a really bottom-up kind of API to allow access to a collection of resources and talking to the collection, downloading the data, all of this without needing the classical workflow of emailing someone or phoning someone, can you give me the data? Yes, this is a link, you can download it. So trying to have a more automated workflow. The second point was about common and persistent identifiers. So to make sure that we are talking about the same thing, it's possible to use the same identifier to refer to it. But it's pointless to do it if that is not persistent over time. So trying to combine the two aspects of common sets of identifiers and persistent ones. Then there is the standards. We didn't recommend single standards, but it was more a way of saying what are the aspects you should keep in mind when you choose a standard. And TI was, of course, one of the examples. If you choose TI as a standard for interoperability, then maybe you have to do it carefully, because, for instance, the number of TI elements that one can have to express the same thing leads to a situation where two TI documents or collections are not necessarily interoperable just because they use TI. And then there was a problem, the aspect of licenses. It's essential when talking about interoperability, also define the licenses and emphasize this point. And we found out that, for instance, from the data sources coming from DARIAH partners, few of them have a real clear specified license for the data. So even if you put up an OAI-PMH endpoint, which is openly accessible, and then you don't say what people can actually do or cannot do with your data, then becomes a problem, not even for machine, but just even only for humans to reuse the data. And To exemplify this, we developed some use cases. And the one I'm talking about today is how to transform a legacy data thesaurus into a more semantic thesaurus. I will first talk briefly about what is the Xenon, which is the OPAC of the German Archaeological Institute, the electronic catalog of libraries, and there are 13 libraries contributing to it. It's a growing set of data, and currently there is 1 million records. So to make sense of this messy set of data, we need a thesaurus to keep it ordered, but also to allow people to access it, finding what they are looking for. And this is the thesaurus of Xenon. Before going to the thesaurus, I just wanted to talk briefly about how Xenon is interlinked with other resources internally at the DI. And one of them is Arachne. You might know it is the object database of the Institute, which started as an image archive and then became more an object database where data are modeled using CDOC CRM, for instance, to relate different pictures of the same monument together and this kind of things. So also the OPAC is one part, apart from picture of objects, another set of data is the digitized images of books that are owned by the DI. And whenever these images are available on Arachne, and the record is also in Xenon, these are interlinked. So if you look up a record which is also there, you can go to the online, to the book browser where there are the scans and the OCR and some kind of TI viewer as well. And when you drill into the content, you might find a picture of a monument, like in this case, and there will be a link from the document in the book browser and the object in the object database. Like in this case, this is redirecting to Arachne. So the thesaurus contains subject entries that are used in the OPAC. It's multilingual. It's not always the case that the labels for concepts in the thesaurus are in all these languages, but they tend to be in English, German, French, Italian, and Polish. Many things in the thesaurus, names of people like gods, ancient authors, modern scholars, but also name of places, modern and ancient ones, names of conferences, for instance, because the OPAC is containing data about monographs, conference proceedings, journal articles, and whenever there is a conference, there will be an entry in the thesaurus also about the conference. As I said already, the OPAC is growing, and currently there is approximately 1 million of records. All these records are in MAC21 XML format. So one problem there was concerning this data set in relation to interoperability is that MAC21 is more about syntactic interoperability rather than semantic interoperability. So if you have, there are guidelines and recommendations about how to use MAC21 to describe library records, but then how you actually do it depends on how you implement the guidelines. So you might have two sets of MAC21 documents meaning different things by the use of the same fields. And the way we tried to solve this was to map, to translate this thesaurus into a SKOS, semantic vocabulary. SKOS stands for Simple Knowledge Organization System, and is the W3C standard for thesauri. The ontology of SKOS is rather simple. There are concepts. Concepts have labels, names that you use to define them. And then to create the hierarchy of concepts, there are two properties, narrower and broader. So one concept can be broader or narrower of another one. And then it can be also related to another concept. So like in this case, you have fortifications to be a broader concept of castles, and so on. So the way we actually did it, and the purpose of the use case was to show that one can use already existing open source software doing a small bit of implementation to transform legacy data to this other format. And we use the Stellar console I think was mentioned in the presentation before, has been developed in the Semantic Technologies Enhancing Links and Link Data for Archaeological Resources project, the Stellar project, by Ceri and Tudhope. What the console is doing, it's a command line tool working on Windows for the time being. Takes as input one of the most basic kind of input. It's a CVS file, applies a series of templates to produce a more structured result. You can use as input CFS and CSV and then get out as output CDoc CRM, expressed as RDF or SKOS in XML and so on. So the workflow also wanted to show how things become easier if people start using interfaces like OAI-PMH to expose data. Because all what I needed to do was to have a small Python script, which was harvesting the OAI-PMH repository containing the Thesaurus, getting all the 121 records, and then again with the script processing them. I had some mappings between fields in MAT21 and properties in SKOS. Made a CSV output, and then I gave this to the Stellar console, which was outputting the SKOS RDF Thesaurus. So one problem there was with this workflow that I'm trying to solve now is that it was running on two different platforms. The first part was working on Linux or on Mac, and then I was constrained to run the second part on Windows for the to actually produce the SKOS RDF. The good thing about the Stellar console is that the templates and the software processing the templates is not dependent from on Windows. The software is ANTLR, and the template engine is called string template. So I'm basically taking the same templates apart from the Stellar console and just doing everything in the Python script, and it's doable. This is an example of the output where you have, okay, so this is a notation for RDF. RDF is a language to express semantic data made of subject, predicate, and object. So in this case, the URI, which doesn't exist yet, which might actually be there in the future, is a concept and has different labels in different languages. So there is a preferred label and then alternative labels. Like liturgy in German is the preferred, and then we have in the different other languages. And the broader relationships, we say the broader concept for this one is this other one, which is archaeology. Then you can also, I didn't say that, but after having produced the Thesaurus in SKOS RDF, I loaded it into a triple store, into an allegro-graphs triple store, and one of the benefits of using that is that there is a client called Graph, with which you can visualize and browse data in two ways. So the first way is this graph visualization, where you have concepts and all the broader concepts and narrower concepts with the labels. And the other, actually more useful to visualize a Thesaurus, is this kind of outline view where you can drill down from a concept and see the narrower and keep browsing the Thesaurus. So it was about 1 million triples loaded in this triple store, and I put a small script that I've done up on GitHub. And also the RDF produced, if someone is interested, is also in the repository. So the strength that I wanted to highlight in this use case is an automated and repeatable workflow. And this is needed, for instance, for our data, because the data, library data, growing and changing periodically. So we want to be able to keep up to date the Thesaurus, running this process regularly and periodically. And then to reduce the human interaction to a minimum. So going from fetching the data to transforming them can be reduced to a minimum using some APIs and other things. And the concept is general and can be, the idea is to reapply to other thesauri. And I really believe that there are many data out there in library catalogs that can be pulled out and transformed and reused in more suitable formats. For the future, the idea of exposing URIs for each of the concepts in the Thesaurus in order to allow other people to link to it, and another perspective is to try to align our Thesaurus with the Library of Congress subject headings, for instance, which is now exposing the data as linked open data, or the virtual authority file. And things that you can do afterwards, when you have converted into a more semantic format, is when you have aligned different vocabularies, is for instance to allow for meta search, expanding queries by to when you want to do a meta search over some data and you have to align vocabularies, you can expand the search key by looking up the word in another vocabulary. So if you're searching for one name in one language and you have aligned with another vocabulary with labels in other languages, you can expand your query and do queries over multilingual resources. That was me. Thank you.